you guys already know stuff about exponents, so I want to focus on the part that I think that's going to give you a harder time. And so what I want you to focus on is, you, as a table, I want you to have discussion, and I want you to explain what is going on with parentheses, negatives, and answers. So you're going to do kind of this exploration together. So I want you to notice, this is old school straight up. I think you guys know that 4 squared means 4 times 4, and that is 16. So once you start looking at some of these have negatives, some have parentheses, some don't, I want you to try to develop a rule for what's happening, like, because the parentheses matter. You'll see some stuff. So as a table, I want you to have some discussion. You might not get the right answer, but your discussion is going to help what we do after this stick, all right? So take 3 minutes or so here as a table and see if you can develop a rule. And then once you've developed the rule, go ahead and try it out. Like, try your theory on it and see what your answers come out as, and we'll see if it's right. All right, guys, I'm interested to hear some things you found out. So what are you thinking? What are you thinking? Lucian.
So if the exponent is odd, but the number is negative, then the answer is negative. And if the number is negative and the exponent is even, then the answer is positive.
What about this?
Yeah.
That's not logical.
So you're saying some good stuff there. This is, I'm intentionally like, okay. Susie, what are you seeing?
So since it's like the negative 6 is not in parentheses, so you do like 6 to the second power, which is 36, then you put a negative in front.
Oh, so let's test it out. Did that work would that work with 2 to the 3rd power as well? What about 2 to the 4th power? Okay, but isn't negative 6 times negative 6 positive 36? Okay, so that right there is where this messes with the heads, right? Everybody see why this messed with the head? Okay, so here's the deal. You guys, Susie kind of pointed out, we kind of found it. Lucian helped. It goes down to the order of operations, but it's kind of nuanced. So listen to these words, okay? This one right here, this one is negative 3 to the 2nd power. So if I were to write that down as an expression, it would look like this. Expanded form, negative 3 to the 2nd power. And negative 3 times negative 3 is 9. So this you know, isn't something you'd have to do every time, but it's going to help make this next one pop, all right? Let's do this next one a different color so it kind of stands. This one here, when we read this one, it reads as the opposite of 6 to the 2nd. So what that looks like expanded is the opposite of 6 times 6. And what it is the opposite of 6 times 6? Negative 36. So that's not actually a negative 6. I know it looks like a negative 6. I get it. When there's no parentheses, our base is 6. And up here, when there are, our base is negative 3. So the parenthesis says this is our base. With no parentheses, it isn't. And where it's really going to show up is later. When we do things like, or potentially do things like exponential functions, you might, or even in order of operations, you might have 12 minus 6 squared. Right? Do you see that? 12 minus 6 squared. Guess what you have to do first with the order of operations there? 6 squared. So that'd be 12 minus 36. And so do you see that's kind of negative then? That's why. In isolation, it sure looks like a negative 6. I get it. All right? So, parentheses aside, Lucian was saying some really good stuff. If I have a negative base, and in order for my base to be negative, it needs to be in parentheses, right? If I have a negative base, an even exponent will give me a positive answer. Why is that? Yeah, Adam.
Because you're multiplying by a negative, and 2 negatives equal positive.
Yeah, so if there's an even number of negatives, they would all cancel each other out to become positive. If there are an odd number of negatives, then there'd always be one left over. They'd all cancel but one, giving us an odd answer. Cool. And I think that's something you already knew. Now, I want to show you one more thing quick. Let's say we had this cube. And you knew this side length was 6. How could I represent the volume of this cube using an exponent? How could I, Lauren?
6. Would it be 6? Wait, no, sorry.
6.
With the 4 exponent.
Monica.
Would it be 6 to the 3rd power?
6 to the third power. Because if it's a cube, I know that my length, width, and height are all 6, right?
Oh yeah.
So 6 cubed. The reason it's called cubed, guys, is because the volume of a cube is length, width, height, all the same.
Isn't area just
So check this out. Let's say we had a square, and I knew this side length was 12. How could I represent the area of that square?
squared?
Squared, which is second power.
144.
Yeah, but we're just practicing representing as a exponent. Callan,
What would be like 12 to the 4th power? How would you show?
4 dimensions? Man, I don't even know.
Hold up.
The fourth dimension, Callan? You're talking about, what is this, the Matrix? I love the question. I'm giving you a hard time. I don't know anything past 3 dimensions, length, width, and height.
12 times 12.
The fifth
Isn't the
dimension.
4th dimension time?
So, Callan, if there were a 4th dimension,
I
to
feel
the,
like an FBI agent.
if there were a 4th dimension, right, you just go to the 4th power.
Everybody just gets a text, stop right there.
All right, so you could be asked for something like, it would tell you like the base of something is 2. That is bad penmanship. The base of, jeez, that was not my fault. That one wasn't. The base is 2, and then it tells you need an answer of like 32, and it wants you to write that as an expression with an exponent. That means you give it a base of 2, and you have to go over here and be like 2 to, I got 4, 8, 16, 32. So I would need that base of 2, 1, 2, 3, 4, 5 times. So my answer would look like this. Okay? If it tells you what the base is and what the answer is, you would then need to find out what the exponent is. That's something else you could be asked to do. How many times would that thing have to double? That's kind of what that is. Yep, 5 times.
Isn't the square root?
Cool.